Tutorial we are going to discuss this question, which written as a diagram of the part y equals to 27 minus x square given. It's a curve equation and the point P and S lies on the curve. This is the P and S, and Q and R lies on the x-axis, and the PQRS is a rectangle. So the length of the POQ is a T units given. So this is the length of the T unit given from here to there, and this is actually the x value. And the find the length of PQ, they are asking the first question in terms of T, and hence show that the area PQRS is given by this. The first part, for doing the first part, we needed to do first, see, if we consider the coordinate of P as a x and y, this is the curve equation which is actually symmetric about the y-axis. Right side of the curve, left side is the same. So length of OQ and length of OR is same here. So length of OR given as a T, and this is the x value, because if I consider P as a coordinate x and y, so this length is called the x value, and from the y-axis the length till to the P, this is the value of the y, x value and y value. So we can write here length of OQ, which is the length of x, we can express as a T. With this length we can find out the length of PQ, which is, we can write here PQ, which is actually the y value. Y written the equation 27 minus x square, we are putting the value here x as a T, so 27 minus T square. This is the length of PQ. So first part we already have done. Now the question is the area of PQRS. Due to the symmetric, the length of OQ and OR is same. So on the right side the length of T, and the left side as well the length of T. So we can write here that therefore RQ equals to 2T. So now it's easy to find out the area. We can write here the area PQRS is given. Area of PQRS, we can write here the length of RQ into length of PQ. One is the length, another one is the breadth. RQ equals to, I wrote here twice T, and PQ it is 27 minus T square. So from here we got 50/40 minus 2T cube. So this is written here as a 50/40 minus 2T cube. So you can write here shown. This is the answer of the first part we already have done. So the second part is written here. Given that T can vary, find the value of T for which A has a stationary point. We know for stationary point we need to differentiate, and we would consider that one as a 0. So if we differentiate the expression of A, which is we got from here 50/40 minus 2T square, if we differentiate we got from there 54 minus 3 to the 6T square, then we need to consider equals to 0. So the expression becomes 6T square equals to 54. Definitely 6 9 is the 54. So T square equals to 9. We got the value from T equals to 3 unit. So this is the value of T which stands for the stationary point. Now the question is third part. We are in the third part, stationary value of A and determine its nature. So we can write here stationary value. We needed to put this value of T in the main equation. Is equals to main equation we need to use 54 into 3 minus 2 into 3 to the power 3. So let me use calculator to do that. 54 into 3 minus 2 into 3 to the power 3, okay, it gives us 108. Let me write here 108. So 108 unit square. This is our answer of the stationary value of A. Now we needed to find out its nature. For finding the nature we have to differentiate again the expression of dA by dt. So we can write it d square a by dt square. This is the double differentiation. If I differentiate the d by dt, which having with dA by dt 54 minus 60 square, 54 gives us 0 and minus 6, it is minus 6 the 12t. So if we put here minus 12 into the value of t, we got 3, it becomes negative 36, which is a negative number, negative value. We can write here the double differentiation gives us a negative value, so we can say a is maximum, a maximum. This is the conclusion of this question. This is the total working of this question. Thanks for watching with patience. You're welcome to see my next tutorial as well.